Hello, my dear students. Let's look at now in this session the fourth case. I have just started the interconnection of energy sources in the last session. Okay, so 3 points we have seen, and on those 3 points we have seen 2 examples. Okay, so now the fourth one, parallel combination of. We have seen what actually series combination of voltage sources, parallel combination of current sources. Now we will see parallel combination of voltage sources and series combination of current sources. Okay, let us see now. There are 2 ideal voltage sources, V1 and V2. They are connected across each other. Okay, I'll place this load later on. Okay, first let me give you. And I want to replace these 2 sources by a single equivalent source. Now the point is, what is its value? You understand? First of all, I think the question must be very clear. Okay, there are 2 ideal voltage sources. One is V1, the other is V2. Okay, I want to replace these 2 sources by a single equivalent source. Tell me, what is that value? What is that value? For example, I have 10 volts here, and then it is 5 volts, let us say. Then what could be the value of V? What could be the value of V? Is it 15 volts or 10 volts or 5 volts or 15 into 5 by 50, 10 into 5 by 10 plus 5, something like that? Any new discoveries of the formulas? Yes. What is that? What is the possibility here to get that value of V? 2 different voltages. First of all, if I connect 10 volts and 5 volts with 2 different values, can you observe KVL in this loop? What's happening here? Plus 10 and minus 10, the KVL is not getting satisfied. In whichever the loop KVL is not satisfied, you know that in one of my previous session I explained you that it results in infinite current. Yes or no? Then it will completely damage the source. That is why we told that the given circuit is invalid. Wherever KVL is not satisfied, wherever KCL is not satisfied, those circuits are said to be invalid. Yes or no? Therefore, if you really want to connect V1 and V2 in parallel or across each other, you must connect those 2 sources with same values. If this is 10, it should also be 10 volts. Now you tell me plus 10 and minus 10 is equal to 0. That is why the most important condition when you connect 2 ideal voltage sources across each other is that V is equal to V1 is equal to V2. That's it. That means you are replacing by a single source, and that value must be what? V is equal to V1 is equal to V2. That means V1 must be always same as V2. Okay, because they are connected in parallel, otherwise KVL gets violated. Okay, now I'm just extending that if V1 is not equal to V2, then you must tell that parallel combination is not possible. Yes or no? Parallel combination is not possible. Why it is not possible? If somebody is asking, yes, because KVL is not satisfied. What will happen if I connect them in force or forcibly? It leads to infinite current. Is it clear, all of you? Okay, that's it. Now, fifth one. Similarly, series combination of 2 current sources. Okay. Series combination of 2 current sources. Okay, assume that there is a load. Okay, otherwise it doesn't make any sense in opening the current source. You already know that. Okay, and I want to replace these 2 current sources by a single equivalent current source. Okay, single equivalent current source, that is I. What is its value? Just like in the previous case, you can see when the 2 current sources are connected in series, Suppose you have 10 amperes here, this is 5 amperes. Then what will happen here? What will happen here? If you apply Kirchhoff's current law at this node, 10 amperes is entering, but 5 amperes is leaving. That means KCL is getting violated. KCL is getting violated. Wherever KCL is violated, you know that it results in infinite voltage and it will damage the source. Therefore, the circuit is said to be what? Invalid. That is why it should not be 5. It should be again 10 amperes is entering means 10 amperes must leave. Okay, it should also be 10 amperes. That means I1 must be always equal to I2 if you want to really connect them in series. Understand all of you? Okay. Then you want to replace these two sources by a single source. Is it possible? It is possible. When they have equal values by a single source, you can say that I is equal to I1 is equal to what is this? I2. Okay. I can just elaborate. If somebody is asking, let us say, if I1 is not equal to I2, then what is your comment? You can immediately tell that the series combination of two current sources is not possible. Is not possible. Why it is not possible? Because KCL is getting violated. What will happen if I connect them in forcibly? If I connect them by force, what will happen? Though the KCL is violating, we know that KCL is getting violated, then obviously wherever KCL is getting violated, how much voltage it results? Infinite voltage. Immediately the circuit gets damaged. Okay. Please note down these important points. Some examples. Some examples. Before we go for the classroom workbook and all, okay, we will see concept and example, Then we will get into the classroom workbook, okay? Hope you have finished that. Please look at this. Okay? Try to answer the question the given here. There is an ideal voltage source. An ideal current source connected across each other. Say this is 10 volts. This is 3 amperes. Now, the question is, listen to me carefully. The question is, whether this combination is possible or not. Okay? If possible, what is the equivalent element that I can replace it by the combination? A single equivalent element. Okay? And third question is, what is its value? There are three questions involved in this, right? What's the first question? First of all, whether it is valid or not. If it is valid, okay, if it is valid, what is the equivalent element that I can replace it by? Right? And what is that element value? So totally three questions are involved in this. Now let us try to answer the first question. First, we need to understand whether it is possible or not. Okay? So tell me whether it's possible or not. Is it possible to go with ideal voltage source and ideal current source across each other? So far we have seen two ideal voltage sources parallel, two ideal current sources series, and two ideal voltage sources series and two ideal current sources parallel. All those things we have already seen. Now the point is, one ideal voltage source and one ideal current source, can we really connect them in parallel? Okay? Can we connect or not? Is it valid or not? How do you check validity? First of all, tell me. How do you check validity? Yes. Whether the circuit is valid or not, how do you check it? A circuit is valid at every node Kirchhoff's current law is satisfied. And in every loop, Kirchhoff's voltage law is satisfied. Both. Again, KCL is satisfied, but KVL is not satisfied. No, it's not valid circuit. At every node KCL, in every loop KVL, if they are satisfied, then definitely the entire circuit is valid circuit, we can say. Now let us try to check. If KCL is happy, KVL is happy, we are also very happy. We also say that it is valid circuit, yes or no? So let us check. Before we verify KCL, KVL, KCL means what? Algebraic sum of the currents. So you need to find current to each and every element. KVL means what? Algebraic sum of the voltages. Should be 0. That means we need to know voltage across each and every element. If you look at now KVL point of view, the voltage between these 2 points is same as the voltage between these 2 points. Then what is the voltage across the current source? Because in case of current source, we know current, but we do not know the voltage. We need to find the voltage. If you find the voltage, what is the voltage across it? Tell me. Definitely this is going to be 10 volts. Now, I think you are very clear the Kirchhoff's voltage law is getting satisfied. Plus 10 and minus 10. So KVL is okay. Yes or no? Okay. Now KCL. To verify whether KCL is satisfied or not, let us try to find current flowing through this 10 volt. Because we know the voltage, but we need to find the current. Independent voltage source concept, what is that? We know the voltage, but we need to find the current. But how much current is flowing? 3 amperes. Can you expect any current in this particular path? No. This entire current is passing what? Here only. Therefore, can I expect the current flowing through this particular source is 3 amperes? Then if you apply Kirchhoff's current law at this node, then what will happen? 3 amperes entering, 3 amperes leaving. Here also, 3 amperes entering, 3 amperes leaving. That means KCL is also satisfied. Okay. In a different way, we can tell that 10 volts will appear across this particular source in order to satisfy KVL. 3 amperes flows in this particular source in order to satisfy KCL. You can also tell like that. Understand all of you? Therefore, finally what's happening here? KCL, KVL are very happy with the combination of these two. Then we do not have any objection. We can say it is a valid circuit. Understand all of you? Okay. So this is a valid circuit. It is a valid combination. It is a valid combination. There is no problem at all. Okay. Now the point is, what is the equivalent element that I can replace it by? Okay. Usually when we ask the questions in our regular classroom sessions, they generally try to answer, 10 by 3 ohm. Some people. I don't know what you people think about it, but what is the answer for it? What is the element that I can replace it? They say sometimes, because there is a voltage source, there is a current source, so why can't we get the resistor? Is it really possible? Okay. Can you really replace the voltage source and current source by its equivalent, that combination by resistor? How come you get the resistor by simplifying the voltage source and current source? It's not possible. Okay. But how do you think about it? You see here, yes, 10 by 3 is probably correct provided if the case is given like this. Look at this. There is a box. There is a box. The voltage across this box is 10 volts. The current flowing through this box is 3 amperes. If somebody is giving this data, you can say that definitely in this box there is a resistor, and that resistor value is how much? 10 by 3 ohm. There is absolutely no problem. There is absolutely no problem. Understand? But this is a different case when compared to this case. So this particular case is not applicable here. You cannot say there is a resistor is an equivalent. It is impossible. Okay? But what is that equivalent element? Look at this. What is the voltage between AB terminals? Here 10 volts, 10 volts and 10 volts. That means 10 volts is appearing here. Let us replace this 3 amperes by 30 amperes. Then what is the voltage here? Still 10 volts. Let us replace this 3 amperes by 300 amperes. Still 10 volts. What does it mean? What is the role of this particular current source on the potential difference between this AB? Is it really influencing the voltage across AB here? No. No, not at all. That means, as far as these terminals are concerned, usually AB terminals are considered to be here in this case, in this particular case, we can consider them as load terminals. Assume that there is a load. some 1 ohm resistor or 10 ohm resistor or bulb or fan or whatever, some load is connected here. As far as load terminals are concerned, the 3 ampere current source can be neglected because it is not having any impact. The value of the current source doesn't have any impact on the potential difference between AB terminals. Is it clear? Then if I neglect this, then what is the equivalent you are going to get again? This 10 volt source only. So I can say it is a voltage source. I can say it is a voltage source AB, and its value is how much all the time? 10 volts, because irrespective of the value of this current source, the voltage across this AB terminals is always 10 volts. Therefore, I can replace that entire combination by what? That's it, a voltage source, 10 volts. Hope all of you understand. Okay. So what does it mean? If you observe closely, now we need to draw certain important conclusion at this stage, because this experience will help you a lot in solving the networks. Look at this. Don't write, I'll give you points. Please do not write anything, I'll give points. Look at this. Now, I'm neglecting this particular current source. Yes or no? I'm neglecting this current source. But how this current source is connected here? A current source is connected parallel to an ideal voltage source. What is the source actually? Is it ideal or practical? Ideal source. If you have a resistor here, that resistor and this 10 volts together can be called as a practical source. But now, the 10 volts is an ideal voltage source. Now, this current source is a parallel to an ideal voltage source. Now, you are neglecting this current source. Not only the current source, in place of this current source, even if you have a resistor, that can be neglected. Even if you have a capacitor, that can be neglected. If you have an inductor, no, inductor cannot be taken. What will happen if inductor is taken? If it is a DC source, it is acting like what? A short circuit. So that is not possible. So who is having a possibility to sit here? Current source is having, resistor, capacitor. Any of these elements, even if you place across this, that can be neglected all the time. So we can conclude that not only current source, any element, okay, any element parallel to an ideal voltage source can be neglected. You got my point? This is a very, very important concept I'm telling you. Any element parallel to an ideal voltage source can be neglected. But remember, this statement is valid only with respect to load terminals. This can be neglected as far as load is concerned. Understand all of you, okay? Only with respect to what? With respect to load only. This replacement is possible only with respect to load. Why you are saying with respect to load, I'll tell you one reason. Okay, please look at this. Don't write anything. Look at this. Okay, I'll give you sufficient time. Plus minus. For example, you have this is 1 ohm, this is 10 volts. Now this is 3 ampere. Okay, this is 3 ampere. This is the load terminals, right? AB terminals. Let me take the load is 1 ohm for the same case. Okay. Now let us see the calculations. I want to find current, voltage, power everywhere or in every element here. What is the voltage across this element? 10 volts. What is the current flowing through this? 10 amperes. Yes or no? Because 10 by 1. What is the power of this element? 10 square into 1, that is 100 watt. Now, what is the voltage across this element? 10 volts. What is the power of this? 3 into 10, 30 watt. What is the power of this? Or what is the current flowing through this? When the load was not connected, because it was open circuit in this case, the 3 amperes you have shown. But now you cannot say 3 amperes is flowing because you have connected load. Now you need to find the current. Current through this particular element you are supposed to find. Okay? Current through any path, how do you find? What is the procedure? Remember, this statement is taken for granted throughout your journey of the network theory or network analysis. That in whichever the path you are trying to find the current, in whichever the path you're trying to find the current, okay, first you check whether that path contains any resistor or not. If that path contains a resistor, you apply Ohm's law. If the path does not contain any resistor, you apply KCL. Remember, current can be determined only either by using Ohm's law or by KCL. Yes or no? Voltage can be determined either by using Ohm's law or by KVL. Yes or no? This statement we have already discussed in one of my previous sessions. Therefore, here this path doesn't contain any resistor. Please do remember, okay, to find the current, we are going to follow the same procedure throughout the entire network theory and network analysis. And this is the way you need to analyze the networks, I'm telling you. This path doesn't have any resistor. Therefore, Ohm's law is not preferable. Now, KCL will help you. Here, if you apply KCL, 3 amperes is entering, 10 amperes is leaving. How much current should flow here and in which direction it must flow to satisfy KCL? 3 amperes and 7 amperes. Okay. How did you identify this direction of current? This direction of current is identified based on the KCL, not based on the polarities of this voltage source. Some people may think that current flows always from higher potential. Not like that, I'm telling you. Okay. This is only to satisfy Kirchhoff's current law at this node. Now tell me, what is the power? 7 into 10, 70 watt. Is it clear? Okay, all of you listen carefully here. Now, according to the statement, any element parallel to an ideal voltage source that can be neglected. Yes, sir, if you neglect, what will happen? According to the statement, if you neglect that plus minus, you have only resistor here. This is the 10 volts. This is 1 ohm. This is AB terminals, right? With respect to AB terminals. This is plus minus 10 volt. Okay. And what about this 10 amperes? Now, what is the power actually here? 10 square into 1, 100 watt. Okay. But what is happening to this current 10 amperes? Then what is the power here? 10 into 10. This is 100 watt. Just compare these two. As far as load is concerned, load is having 10 volts, 10 amperes, 100 watt in the first case. After neglecting this element also, you got 10 volts, 10 amperes, 100 watts. Yes or no? That means, as far as load is concerned, okay, whether this current source is present or absent, it doesn't make any difference. It doesn't make any difference. Even if you neglect, you are getting the same values to the load. That is why, as far as load is concerned, this can be neglected. But in the same question, if somebody is asking, what is the current flowing through 10 volts? Can you neglect it? No, because when the current source is present, the current flowing through the voltage source is 7 ampere. When the current source is absent or neglected here, the current flowing through 10 volt source is how much here? 10 amperes. But which is correct here? This is correct, that is not correct. You understand, all of you, okay? So, the statement, that is why with respect to load only, this is possible. That is, neglecting this current source is possible as far as load terminals are concerned, as far as the load is concerned. If somebody is asking what is the load current, what is the load voltage, what is the load power, you can neglect it. If anybody is asking, let us say, what is the current flowing through this voltage source, or what is the current through this voltage source, or what is the power of this particular voltage source, you are not supposed to neglect it. I think it is very clear. This is a very important concept. One must really understand the network analysis, okay? So please note down, and I'll give a statement. Which is very, very important after noting down all these things, okay? First, you note down this. Don't write this part, I'll tell you. Don't write this part, okay? This part I will tell you. Whenever I tell, then only you write this part. First you write this. Voltage source, current source is neglected and replaced it by 10 volts. And write in the bracket with respect to load only. And then you put a note and write down. Then you put a note and write down. I'll dictate the point. Please note down that point. any element parallel to an ideal voltage source can be neglected. Any element parallel to an ideal voltage source can be neglected. But this statement is valid only with respect to load, yes or no? So therefore in bracket you write only with respect to load. 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 Okay? So the statement we have given, right? And only with respect to load we have mentioned, right? For that, the justification is, please note all this. Please note all this. The justification. The statement is given for that justification. Why we are telling only with respect to load? Because as far as load is concerned, there is no problem even if you neglect it. But if you neglect this, there is a problem for the voltage source. We are getting the current 10 amperes instead of 7 amperes. In fact, 7 amperes is the correct answer, not 10 amperes here. Okay? Please note down. Second example. Yeah, assume that there is a load. Otherwise, I told you already several times that the current source must not be open. Okay? Assume that there is a load. Otherwise, it's meaningless completely. Now tell me whether this combination is valid or not. Note down that whether that combination is valid or not. I think all of you noted on this, right? Please do that first. Okay. Now note down this particular circuit as well and check whether it is valid or not. So our question is always simple now in all these examples, whether circuit is valid or not. If it is valid, what is the equivalent of those combination? I want to replace by a single element. And what is that element? And what is its value? Okay. Now how do you check the validity here? Definitely through KCL and KVL. Yes or no? In case of voltage source, you find current. In case of current source, you will find voltage. Now, current, how much flowing here? Because these two are in series. All the time, the current flowing in this path is 10 amperes because there is a current source, right? So, what is the current that you can expect here? 10 amperes. What is the voltage across this particular current source? It depends on what is the voltage across this. So, if I know the total voltage, I can find what is the voltage across the current source. But now I think KCL is satisfied because current is 10 amperes. Now current is 10 amperes. Entering 10 and leaving 10, obviously KCL is okay. So KCL is happy. Or else people say that in order to satisfy KCL, the current always flows in this direction is 10 amperes. Okay. Therefore, there is no problem with the KCL. Okay. Now KVL. Assume that this is 1 ohm. Okay. And if this is 1 ohm, how much current is passing here? 10 amperes. So 10 amperes is flowing here. What is the voltage here? 10 volts. If this is 10 volts and this is 3 volts, obviously what is the voltage here? 7 volts. Yes or no? 7 volts. How did you get the polarities? Polarities are placed based on the direction of current source here? No. We are not placing the polarities based on the direction of current source here. We are placing these polarities keeping in mind Kirchhoff's voltage law in this loop. If you place the polarities plus minus, then only KVL is satisfied. Look at this. Plus 10, plus 3 and minus 10, then only the KVL is satisfied. Yes or no? So remember, we are not going to place the polarities based on the direction of current. We are not going to place the direction of current based on the polarities of the voltage source. For active element, okay, you cannot think like that. In case of passive element, you can think. See, this is the passive element. I know the direction of current. I can indicate the polarities. If I know the polarities, I can indicate the direction. But for active element, it's not like that. I will tell you how you think about it. Okay, active convention is different. Passive convention is different. Understand? Okay. Well, now KVL is satisfied. Definitely KVL is also okay. To satisfy KVL, definitely 7 volts will appear here. So KVL is also okay. Therefore, it is a valid combination. Therefore, it is a valid combination. Okay. Now, with respect to load, what is the current all the time flowing here? 10 amperes, irrespective of this voltage source value. 3 volts, 10 amperes. 30 volts, still 10 amperes. Yes or no? 300 volts, still it is 10 amperes. What does it mean? The impact of this voltage source, does it have any on the load? It does not have. Okay. So even if you neglect this particular voltage source, it doesn't make any difference as far as load is concerned. That means this element can be neglected. Not only this element, in place of this, even if you have a resistor, that can be neglected. Even if you have an inductor, that can be neglected. Even if you have a capacitor, no chance. Because for DC current source, the capacitor acts like an open circuit. If it is open, the current source is open, current source must not be open. So the capacitor does not have any opportunity to sit in the place of the voltage source here. Who is having the opportunity to sit here in series with the current source? Voltage source is having. Resistor, inductor. Only these three elements are eligible to sit in this place in series with the current source. You understand all of you? Okay. Now, can we neglect this particular element? Yes. And what is that equivalent you are getting all the time? Current source. And what is its value all the time? How much it is flowing? 10 amperes. Okay. Now, here you have a load. Okay. But all this is valid only with respect to what? Load. Understand? Why I'm telling again with respect to load? Because when voltage source is present, the voltage across the current source is 7 volts. When voltage source is absent, the entire voltage 10 volts will appear across what? The current source. Now you tell me, what is the current voltage power all the time here? Even though it is neglected or it is present or absent, it is not changing. So as far as load is concerned, there is no problem. But when this particular source is neglected, now this is experiencing 10 volts. But what is the voltage across the current source? If somebody is asking, what is your answer? 10 volts or 7 volts? 7 volts only. What is the power here? 7 into 10, 70 watt only. You understand all of you? Okay. Therefore, write on the point. Note. It's a very important concept. Okay. If you do not catch the points, you please watch it again and again. Otherwise, I'm telling you, because this is the crux part of the network analysis. Most of the people do not understand. They simply by heart. These particular elements are in series, therefore can be replaced. That's it. But why? Okay, why it is so? Because in interview, definitely people will ask you simple question. You can't expect a big network and solve it using node analysis or mesh analysis. That part you have already done in the written test part. They will expect something else in the interview. So be careful. Concepts are very important. And you might be knowing that already in almost all PSUs, 70% or 80% weightage is given to the gate score and the remaining 20 to 30% weightage is given to the interview. So if you're not strong enough or, confident enough of your fundamentals, probably you may lose the opportunity. Even in getting an IIT admission, MTech in IIT admissions, most of the IITs, the topmost IITs for certain specializations, they are not directly taking through your gate score. They're again inviting the candidates, gate scorers, their gate rankers, for an interview. So when you face an interview, okay, you need to face it. You need to face with all the simple questions they will ask you, and definitely you will be in trouble if you are not really confident. That is why I'm telling you. Okay, if you do not understand one time, you watch it again or you watch it again. Okay, and if you have any doubts, I've shared my contact number. You can also talk to me, or you can just send a query. I can definitely clarify it. Okay, so please quickly note down. Right on the point here. Any element in series with an ideal current source. Any element in series with an ideal current source. No doubt. Any element in series with an ideal current source can be neglected. Any element in series with an ideal current source can be neglected. In bracket you can write, as I explained you, in bracket you are supposed to write what? The statement is valid only for what? Only with respect to load terminals. Only with respect to load terminals. Now, third example. Is it valid or not? Yes. Is it valid? Two voltage sources are connected across each other with respect to AB terminals. Check what is this value 5 into, what is this Vx value here? It is only 3. So what is happening here? 15 volts. How can you connect a 3 volt source across a 15 volt source? KVL is getting violated. Yes or no? Okay. Therefore, the circuit is invalid. Invalid. Okay. Similarly, if I place a current source here, now tell me. Now tell me here. What's happening? 5 into 3, that is 15 amperes. There's no problem, right? If voltage source and current source are across each other, connected across each other with respect to AB terminals, it is valid, and the equivalent will become what? Simply with respect to what? AB terminals. You can neglect the source all the time, and this value is 3 volt. Fifth one. What is current I? Option A, 10 amperes. B 20 amperes, C 3 amperes, D none. Okay, look at this. 10 amperes, 20 amperes, 3 amperes, none. Okay, how do you answer it? When you have none, you must be little careful. Sometimes you have to watch the network carefully. Otherwise, you may commit a mistake. Look at this. Sometimes people think that, okay, 10 volts is there directly appearing, therefore 10 by 1 is 10 amperes. The first option is readily available. You must be careful. You check here 15 and these two, minus of minus 5, 20. And in this loop, the Kirchhoff's voltage law is not satisfied. Look at this. A 20 volt source is connected across parallel to a 10 volt source. For a parallel combination, two voltage sources must have the same value. So is it valid or invalid? Definitely it is an invalid circuit because the KVL is not satisfied in this loop. Sir, current source is there? Yes. Even though you have a current source, okay, but in every loop, this loop and this loop and this loop and this loop also, in every loop KVL must be satisfied. Okay, but this particular loop, now the KVL is not satisfied. I am selecting this particular loop. Right? So, once the KVL is not satisfied, then it is an invalid circuit. You cannot, first of all, okay, you cannot find anything here and the circuit itself is invalid. If you forcibly connect like this, the circuit will get damaged. Okay, so this is all about the interconnection of energy sources, and we are supposed to deal with another important concept. Okay, so please note down this. Let's suppose discuss another important concept here. Hope you have noted down. Okay, that concept I stop here in this particular session, and that concept I will discuss in the next session. Okay, we need to